Beautiful. Now we've found out a little bit more about our data frame. What we're going to do now is compare different columns to each other. And the reason being here is because this is helpful to help us start gaining an intuition about how the features, so these columns here, relate to the target variable. So that's what our machine learning model is eventually going to do, right? It's going to search through the different columns of our data frame and then figure out the patterns as to what target value is associated with values here. Now, we could do much the same. If you just went through this row by row, you would start to gain an intuition about what values associate with what target value. But let's stop talking about it. Let's visualize it. So what we'll do, the first two columns we might compare are age to target. So we go here, frequency according to sex. So this is what we want to do. We want to compare the sex attribute to the target attribute. So what we might do is go df.sex.valueCounts. Here, there's no real pattern of how we're doing this. We're just kind of exploring the data. All right, so we see here, there's a lot more male to female. So female is 0 here, that number, and male is 1. The reason why I know that is if we go back up to our data dictionary, if we look here, sex, 1 equals male, 0 equals female. Wonderful. So we come down. So we know our data set is a little bit tilted towards having more males than females. If we wanted to compare the sex column to the target column, a handy function in pandas is the pd.crosstab. So let's have a look at that. Compare target column with sex column. PD crosstab. We're going to pass it df.target with df.sex. Beautiful. So this is going to give us some information here. What can we infer from this? Well, what we could do to begin with, before we even build a single machine learning model, is make a simple heuristic. So since there are about 100 women, right? If we add up this, so if we see sex is 0, and this is comparing the target column to the sex column. So since there are about 100 women, and 72% of them, or 72 out of the entire amount of women, have a positive value of heart disease being present. So see here, the target is 1. So that means an indication that they do have heart disease. What we might infer based on this one variable, if the participant is a woman, so if the sample, if we come back up here, if the sample in our data is a woman, there'd be roughly a 75% chance she has heart disease. The reason being is because here we've taken about 100 or so. Again, we're just rounding here. And if we add these up, that's going to equal 96. But if we see here, just looking at this comparison between sex and target, 72 out of 96, so basically 75 out of 100. So what we're inferring from this, before we even build a single machine learning model, if a woman comes and we're trying to figure out whether she has heart disease or not, based on our existing data, based on our existing data set, 75% chance that she has heart disease. Again, remember, based on our existing data set. It might be different in the real world. And so if we look at male, there's about 200 in total, with around half indicating a presence of heart disease. So see there, 93, target equals 1, where sex equals 1. When the sample is a male, 93 out of 207 indicate that there is heart disease. So if we looked at this, if the participant is male, we might predict around half the time that participant will have heart disease. And then if we average these out, we'd get 75% plus 50% over 100. You get about 62.5% chance that anyone, of course, this is always based on our existing data because that's the only patterns that we can find is with the data that we have. So based on our existing data set, this up here, if we were to see a random patient, we're making our decisions whether that random patient, a new patient we haven't seen before, We're making our decisions based on our existing data set. And based off this comparison alone, we might infer that there's a 62.5, remember, about 75% if they're a woman and 50% if they're a male. So we're just adding them together and averaging them. So 62.5% chance that they have heart disease. Now, this is our very simple baseline. And what we're trying to do here is just form an intuition in our head about the data set, about how different features, in this case, we're doing the sex feature, the sex column, we're comparing it to target. So if we would just use that one feature alone, if we were to expect a patient to come to us, we'll go, okay, any patient at all, there's a 62.5% chance that they have heart disease. And now, with that baseline, what we're going to try and do is beat it using machine learning. So again, if this is a little bit confusing, don't worry, it's a little bit confusing when I first started figuring out patterns, but the main thing to remember is all we're doing is just creating an intuition. We're becoming subject matter experts on the data, or at least trying to. And so what we might do is make this a bit more visual. Create a plot of crosstab. We go pd.crosstab, df.target, df.sex, and then we can go .plot, and we'll do it as a kind of bar. We'll give it a fig size, just because we want it to come out. We'll go 10:6, so that's width and height there. And then we'll give it our famous color that we're going to work with, which is, we'll do salmon and light blue. Wonderful. Beautiful. So this is another visualization that we can start to get an idea. And it shows it a little bit more intuitively than just a crosstab. So if we look here, we've got target, which is 0, not heart disease. And this is sex, 0 or 1. So we can see that the people who don't have heart disease, there's far more male. And we can see here that the people who do have heart disease, now there are more males that do have heart disease, but if we look at the ratios compared to each column, so this one is male, blue is male, and the salmon color is female. If we compare these columns, we can see that the females who do have heart disease is about a 3-to-1. If you would just compare those visually, about 3-to-1, right? So that's where we're getting a 3 and 4 chance of a female at random having heart disease. But males, the ratio is kind of, and it's definitely not completely even, but it's a lot closer than what the females are. Wonderful. So if we wanted to add some titles to this, we could add some communication here, such as maybe we go plt.title, heart disease, frequency for sex, and then we go plt dot, maybe we add an X label, and we go 0 equals no disease, 1 equals disease. We might go plot Y label. We might put amount here. Then maybe a legend, because we might change this legend. See if we can update that to, rather than being 0 or 1, so we want to communicate this to someone. We're doing some data analysis. They don't know what 0 or 1 means. So we want to do female, male. Actually, I'll show you what this does before we even do it. So let's do that. We'll add a little semicolon here so we get rid of that. What are we missing out here? Oh, I forgot legend. That should work. Wonderful. So that's a little bit more intuitive. And so this is what I wanted to change here. I wanted to get them vertical. So what we might do is plot X ticks. These are X ticks here, little ticks that are labeling. So we go plot X ticks, and then rotation equals 0. This took us a little while to get set up, but really if you're going through this, you might breeze through it if you're going through it by yourself. But if we want to communicate it with someone else, we better design it in this way, because we may know the data ourselves, but if we just want to share this image so someone else has an intuition over the comparison of who has heart disease depending on what sex they are, they won't know what we know with the data. So that's why we're making our visuals as communicative as possible. All right, now that we've compared 2 columns, we've seen how to do it. What we're going to do in the next few videos is compare a few more. So take a little break, reflect back on what we've gone through here, maybe try compare 2 columns of your own. Usually you compare the target with a single column here, and you start to work out the patterns.